To question number 4 of exercise 8.2. In this question it is given that ABCD is a trapezium and in which AB is parallel to DC and BD is a diagonal. E is the midpoint of AD and also EF line is drawn in such a manner that it is parallel to AB. We have to prove that F is the midpoint of BC line. Now let's start the proof. Let us take this point as some other, let us name it. Suppose this is O. Now in triangle ABD, E is the midpoint of AD given and EF is parallel to AB given. This implies if EF is parallel to AB, then EO is also parallel to AB. Its part, because if full line is parallel, then the part of the line is also parallel to the same line. So in triangle ABD, we have proved that E is the midpoint of first line and EO is the line parallel to the second line. Then this line joining is the this is the midpoint of the third line by the midpoint theorem, by the converse of midpoint theorem. Then by the converse of midpoint theorem, state that then it is the midpoint of the third side, means O is midpoint of BD. This implies OB is equal to OD. Call it equation number 1. Clear up to this point? Now in the same manner, now we will take this triangle. In this triangle we have proved that O is the midpoint of BD and OF is parallel to AB. Then OF will be parallel to CD also, because AB and CD are parallel. This line is parallel to this line, then this point will be the midpoint of the third side and hence the proof of the theorem. In this way we will prove. Now take in triangle ABCD. In triangle BCD, O is midpoint of BD, just proved by equation 1. We can write just proved above, and OF will be parallel to CD because OF is parallel to AB and AB is parallel to CD or DC. Then if the two lines are parallel to the same line, then they are parallel to each other. So OF and CD are or DC are parallel to each other. Then in this triangle, with the converse of the midpoint theorem, F is midpoint of BC. By converse of midpoint theorem, because converse of midpoint theorem states that if one is the midpoint and the line joining is parallel to the second side, then that point is the midpoint of the third side also, and hence we have proved that F is the midpoint of BC, hence the question.